who better than them? Who better than them to tell how grave the situation is? And it's that time of the year, especially in the Delhi NCR area, where it's in the news, unfortunately for the wrong reason of very low AQI. And in fact, the other day, a colleague of mine was saying that it's getting better. The severity has come from very poor to poor. So that's still not good enough, is it? So how can we make it good enough? What kind of policy interventions, and equally importantly, from more technology solutions need to be brought in to really achieve the kind of environment, the kind of air quality that we deserve. So on that note, I once again welcome you on behalf of ET Auto to this very, very special webinar. And it's my pleasure to announce that we have with us Pallavi Pant, who is the head of Health Effects Institute. She joins us from the US. It's a little bit of an odd hour there, but really appreciate Pallavi for really keeping up late today and to participate in this webinar. Welcome, Pallavi. And we also have Kaushik Deb. He is from the he heads the Energy Policy Institute at the University of Chicago. And welcome, Kaushik. Thank you for joining us. And now let me welcome Amit Bhatt, who is the Managing Director, India of ICCT. So over to you, Amit, for your remarks.
Thanks a lot, Sumantra, for giving the context. And someone who's kind of speaking from Delhi, I can vouch that air quality is definitely a major issue. And on the unfortunate side of it, it's now become mostly the winter conversation. We talk about air quality maybe somewhere around October, November, and till the end of this year and early next year. We forget about it till the next winter comes. But data shows that air quality has a couple of important dimensions. One, it's not a Delhi problem. In fact, it's a national problem. It's just that it is slightly more aggravated in the Indo-Gangetic plain. So air quality is not a Delhi conversation, it's a national conversation. So that is one. Second, air quality is not a winter issue. I mean, if you look at the year-round data, we hardly have any good air days. Most of the time it is bad days, very bad days, severe days, or so on and so forth. And third, very important point is that it can be managed. I mean, we can really improve air quality, and we have seen examples from around the world. The cities have done considerable improvement in air quality in a limited short span of time. So if we do the right things at the right time, then I think we can really see the impact on air quality. So very thrilled to be ICCT to be partnering with ET Auto on this topic. And my colleagues Anirudh and Murthy will share two interesting case examples. On one side, we'll be looking at once we create low emission zones, what's the impact that can have on the air quality. And second, we will get slightly more deeper into understanding the real world emission from transport vehicles. Because Sumantra, as you might be knowing, that if you look at the data from Delhi, within Delhi, the major source of emission, if you look at particulate matter emission, is from transport. And so if we have to do the transport right, we have to first understand the severity of the problem in more detail. And the study that we have done looks at the real world emission. So very excited. And again, thanks a lot, Kaushik and Pallavi, for joining, and looking forward to some interesting conversation today.
Thank you there, Amit. And as you rightly said, we need to first understand the size, or in this case, the severity of the problem, before we kind of discuss what the solutions could be. So I'm pretty sure the following presentations will really enlighten us on that. So without further ado, let me invite on this virtual stage Anirudh Narla for his presentations on the findings from the real world motor vehicle exhaust emissions in Delhi and Gurgaon using remote sensing. So over to you, Anirudh.
Thank you, Mr. Sumantra and Amit. I'm sharing my screen. Is my screen visible?
It is. It is. Please go ahead.
So, as Amit highlighted, I mean, there are multiple sources of pollution for the deteriorating air quality in Delhi, but different studies have consistently flagged transportation as one of the major sources. Like, the position of transportation varies, but it consistently figures in the top three when we look at from the perspective of particulate matter. But when we look at from the perspective of other major transport pollutants, for example, like NOx, carbon monoxide, transport is actually the leading contributor to these emissions within Delhi NCR. As you can see on the right side, this was an estimate by ARAI and TERI, a source apportionment study. While transport is being shown as the leading contributor to finer particulate matter, it is also overwhelmingly the leading contributor to NOx, carbon monoxide, and volatile organic, non-methane volatile organic compound pollution in Delhi NCR. So, I mean, this pollution, it's not just from the perspective of vehicular emissions and controlling vehicular emissions. This has been rightly identified by the authorities as the topic of air quality and health. As we daily see in our news reports, the curbs on vehicles or any older vehicles or diesel vehicles are being coupled with the messaging of air quality or health. Now, coming to India's vehicle emission standards, as few of you might be aware that India has this these emission standards called Bharat Stage Emission Standards, which started back in 2000. Prior to 2000, we did have few emission standards, but not very robust ones. But starting from 2000, these Bharat Stage Emission Standards, which followed Europe's Euro standards, have been rolled out. And as you can see in the picture here, all the major standards until BS4, these were rolled out earlier, first in major cities like Delhi and Gurugram and Mumbai, and the rest of the country then followed. For example, the BS4 standard was rolled out in Delhi back in 2010, whereas in the rest of the country, it started from 2017. But coming to BS6, which is the latest emission standard currently that we have, this was rolled out overnight, starting from 1st April 2020. And India is also the first and only country until as of date to have leapfrogged from BS4 to BS6 emission standards for vehicles. Now, what is the current vehicle testing regime in India? It broadly looks like this. One is prior to the sale of the vehicle, where a manufacturer has to go to the government of India and has to get it certified for emissions. As you can see, India traditionally had this lab chassis dyno testing for light duty vehicles and engine dyno testing for heavy duty vehicles, where gas analyzers are used and particulate matter analyzers are used to get the emissions readings in lab conditions. These used to be compared with some set lab limits. But starting from April 2023 onwards, India introduced the real driving emissions regulation, where we started using this PEMS device, the portable emissions monitoring system. As you can see on the red car on the right, there is a white box attached at the back of the vehicle. So this basically PEMS device helps us to capture the on-road emissions when a vehicle is running on the road. So this testing has been mandated into the type approval and conformity of production stages for Indian models that are being introduced into the Indian market. The other testing, which is a very widely known testing, the PUC, Pollution Under Control Certification testing, which is done annually or biannually depending on the emission standard of the vehicle. Basically, in this we use multi-gas analyzers for petrol and CNG vehicles and opacity meters for diesel vehicles. For petrol and CNG, we capture hydrocarbons and carbon monoxide, whereas for diesels, basically we are capturing the opacity readings, which is a loose proxy of particulate matter. While the RDE regulation is a very relevant and required and right step in the right direction, it comes with its own set of limitations. It is an intrusive form of testing where the PEMS device has to come into contact with the vehicle for it to obtain the readings, and it can be tested on a limited number of vehicles in a given time frame. Maybe in a day, if everything is planned out well, you can go ahead and test 5-6 vehicles, and it is also relatively expensive for testing and maintenance. On the other hand, PUC testing, many of you might be aware, like it does not capture the real world emissions, and the testing is done in ideal state testing. It is basically an ideal state testing. So there are no real world, I mean, when the vehicles are running on road, they emit differently as compared to ideal state. So these real world emissions are not captured in the PUC regime. And it also misses out on key pollutants like NOx and particulate matter, because we are not capturing these readings anywhere during our PUC testing. And back in 2017 or 18, a report to the Supreme Court of India also highlighted how there could be potential tampering and evasion or fraud related to this PUC testing. Now, why is real world emissions testing? So with this information, why is real world emissions testing important? Almost a decade back, like this study came out, which was the famous or infamous Dieselgate scandal, where a manufacturer was caught in the US when the manufacturer's vehicle were tested on the road. The vehicles were emitting almost 20 to 30 times more than the laboratory conditions. So this is one of the pivotal moments where different regulatory authorities across the globe realized the need for having robust on-road emissions testing rather than just relying on lab testing. So this calls for a surprise on-road test, which kind of complements the periodical emissions testing that we or any other country has. And this could be in different forms, but one of the most effective forms, which can be done in a non-intrusive and a mass scale, is using this device called remote sensing device. As you can see on the slide on the left, the remote sensing devices come in different forms. They basically work on the principle of optical absorption spectroscopy. It could be a top-down equipment, as you can see on the top figure, or a crossroad equipment, the kind of equipment which we used in Delhi and Gurugram. So basically, you have a source module on one end of the road and a detector module on the other end. The source module throws out infrared and ultraviolet rays, which pass through the diluted exhaust plume of the vehicle, and these get absorbed at the characteristic wavelengths. Each pollutant has its characteristic wavelength, and the differential in the reading that we obtain in this is what we get as the emission reading. The pollutants that we can capture are NOx, oxides of nitrogen, hydrocarbons, carbon monoxide, and also the opacity reading, which again is a proxy for particulate matter. The latest gen equipment can also capture ammonia readings. So how can this remote sensing data help? Like, what is the need for this remote sensing data is that in a given period of time, like few hours or few weeks of testing, we can capture thousands of emissions records, on-road emissions records. So what this helps in is that, for example, if we have, as you can see on the slide, if you have, let's say, 1,000 data points, you can do emissions analysis at the average emissions analysis at the fleet level. Whereas if you further have more data points, you can do the emissions analysis at vehicle type versus fuel type, or vehicle type versus fuel type versus emission standard. So this can go to the extent of identifying which fuel type is emitting more, or which emission standard kind of vehicles are emitting more, or even to the point of which model or which manufacturer or which engine size is emitting more. So that is the power of remote sensing data, where you can gather lakhs of records in a short period of time for robust analysis. Now, how good is this technology? This technology, as you can see on the slide, has been compared against what you can say is the considered as a golden standard of emissions testing for vehicles, which is PEMS. So as you can see, PEMS versus remote sensing were compared. This was done in Europe, in the Swiss by a Swiss agency, where almost 350 PEMS readings were compared against 65,000 or 70,000 remote sensing readings, and both technologies showed very close or very good agreement with each other, as you can see on the figures which are being shown here. So also, what is the need for capturing on-road emissions, that too using remote sensing? Here is one example that you're seeing on the slide. As I mentioned earlier, India and other countries, they have this lab emissions testing. On the x-axis, you're seeing the speed, and on the y, you're seeing the acceleration. The speed acceleration profile in lab testing is always limited, because these are done under fixed set of conditions. On the top right, you can see NEDC, which is New European Driving Cycle. MIDC is a modified form of NEDC, which stands for Modified Indian Driving Cycle. You can see how limited MIDC is in terms of speed versus acceleration profiles that it captures. Whereas on the bottom right, you can see how wide range of conditions that remote sensing captures during the testing. Now, this is a technology that has been in use. This is not a new technology. It has been in use for more than 3 decades in countries like US and in regions like Europe and China. For example, this is a very good example coming from London of how this remote sensing data has been leveraged to take actions against gross polluting vehicle segments. The iconic black diesel cabs were found to be polluting disproportionately high. As you can see, the red bar here is the emissions from these black diesel taxis. Even with progression in emission standards, the emissions from these vehicles were remained high, even almost 10 to 12 times higher than the lab limits. So what the authorities, basically the mayor for London, did is that they had this data, they took feedback from this data. There was already a policy in place which required for these cabs to shift to zero emission vehicles. Basically, this data accelerated the transition to zero emission vehicles for this particular vehicle segment. Another good example that we have is from Hong Kong. How Hong Kong does is that Hong Kong has defined remote sensing thresholds for each of the measurements, like for the measurements that they do. So as you can see on the bottom left, there are 2 sets of remote sensing devices placed on either side of the road. And when a vehicle passes through both these devices, and when the vehicle comes out as high emitter as per both the readings from both these devices, the vehicle owner is sent a notice or a message saying that your vehicle is identified as a high emitter by the remote sensing, and the vehicle owner is given almost a couple of weeks time to get it rectified. And after a couple of weeks, the vehicle owner has to go through a lab test, basically the chassis dyno test, which is there in Hong Kong. And if the vehicle passes the test, the vehicle license is retained, it is fine, it can run on the roads. But if the vehicle fails this lab test, then the registration is discontinued. As I mentioned earlier, like this remote sensing offers a wide range of use cases. One of the use cases is, for example, for researchers, it is very important to have real world emission factors to understand the impact of vehicular pollution and different vehicle segments on air quality. That is one. And development of evidence-based policies. Earlier, when Amit spoke about different policies, he also mentioned something called low emission zones, which will be discussed later. So this kind of mass data will aid in development of such policies, and also for high emitter identification and low emitter screening. For low emitter screening, there could be some exemptions from, let's say, PUC testing. So that is the advantage of low emitter screening. So a remote sensing in India, basically this remote sensing is existent in India. It has been in use since 2009 based on the direction of Calcutta High Court. One device has been procured by the Transport Department of Calcutta, and they have been using it since 2009. And following that, in 2015, NGT also remarked that ideal state emission testing will never depict correct data, and it directed CPCB and DPCC for procuring devices that can capture real world emissions. CPCB then directed the state governments within NCR back in 2015 to deploy remote sensing devices. And again in 2019, under its National Clean Air Program, it reiterated this action point to all the 131 cities. And things really started moving when Supreme Court intervened back in 2018, saying that remote sensing has to be deployed in Delhi NCR. It reiterated its direction in 2019, and again this year, back in July 2024. So we can expect some movement on this. So based on all the push from different judicial agencies, Ministry of Road Transport and Highways has come out with a draft technical standard for remote sensing devices in September 2020. Though this standard is yet to be finalized as of today. So with this background, we did get a remote sensing device into Delhi with the objective of developing a new understanding of real world emissions of Delhi vehicle fleet, and also provide guidance to the policymakers for mitigating vehicle pollution. We targeted to capture at least 1 lakh vehicle emissions measurements. We also did some training for the officials from 7 different states on this technology. So different lanes, basically there are certain parameters on how sites are to be selected for this testing. The most important parameter is having a single lane traffic so that the device can capture these emissions properly. Overall, our testing was done from December 2022 to April 2023. Around 20 sites were selected for the testing, and we captured 4 different pollutants: carbon monoxide, hydrocarbons, NOx, and UV smoke, which is a proxy for particulate matter. We captured all vehicle segments except for medium and heavy duty trucks. We could not capture this particular vehicle segment because there were plying restrictions at that time in Delhi on this vehicle type. And almost a third of the fleet that we captured was CNG. This was also the first remote sensing study that captured such a significant number of CNG vehicles. We collaborated with Transport Department of Delhi, Deputy Commissioner of Gurugram, NHAI, and Gurugram Police Department, Delhi Police Department. So, of course, almost 53% of the fleet that we captured were Delhi registered vehicles, because the number of testing sites were more in Delhi, followed by Haryana, almost 28%, and UP, and then other states. So this is the fleet composition that we were able to capture. BS on the right, you can see in terms of emission standards. So BS4 and BS6 vehicles accounted for almost 89% of the captured fleet. Pre-BS4 was only 11%. This is also due to the fact that BS4 was rolled out pretty early in Delhi back in 2010. On the left, if you can see, the dominant vehicle type that we captured was private cars, followed by taxis, followed by two-wheelers, three-wheelers, and light goods vehicles. I'll just take a minute here to explain how different policies of the government can reflect on the vehicle fleet that is running on your city's roads. For example, if you see in private car, for the bar of the private cars, you can see a mix of all three fuel types: petrol, diesel, and CNG. Whereas for the same car segment, in taxis, you will see it is entirely dominated by CNG. The major reason for this is one, curbs on diesel vehicles, but apart from that, the Delhi government restricts the licensing to taxis which are non-CNG and non-electric just for 8 years. So only the CNG and electric taxis will get extensions beyond 8 years. How do the emissions results look? As you can see, with progression in emission standards, the emissions reduce. There are a few vehicle segments which deviate from this. For example, BS4 buses. That is because of the reason that the BS4 bus fleet had a significantly higher average engine size as compared to BS3 bus. But barring that, as you can see, starting from BS1 to BS6, as we progress with each emission standards, the emissions have been reducing. Just a zoomed out version that you're seeing on the right is BS4 versus BS6. As you can see, this reduction was to the tune of 60%, 70, 80, and in some cases even 90% when we compare BS4 versus BS6. This is across vehicle types and fuel types and pollutants. So here again, I'm showing a very similar data point which I spoke about in the previous slide. Basically on the left, you're seeing how the emissions are reducing for two-wheelers when we move from to the latest emission standards. For example, from BS4 to BS6, as you can see, there is a reduction of 20% to 68% based on the pollutant. And for taxis, again, you can see the decrease from BS4 to BS6. It is pretty high, 60, 70, 80% in some cases. But though we saw drastic reductions in terms of real world emissions, what we are seeing here is that even within BS6 fleet, or let's say CNG fleet, CNG which is considered as a cleaner fuel option or a transitionary fuel option, we are finding real world emissions much higher than lab limits or lab values. As you can see, for light goods vehicles, especially the light goods vehicles class 2, the real world emissions were almost 14.2 times higher than the lab limits, which is significantly high. I'm not showing the BS4 data here, but in the report you can access the BS4 data too. For BS4 light goods vehicles, it was almost 25 times higher than the lab limits, meaning the light goods vehicles are emitting 25 times high NOx than what they were doing in lab or what they were supposed to do in lab. And this is the case across different commercial vehicle segments. As you can see in the figure on right, the private cars, though they are emitting almost twice the lab limit, they are significantly lower as compared to other commercial vehicle segments. Whereas three-wheelers, taxis, light goods vehicles, they have emissions much higher than private cars. And I'm talking about CNG here, which is considered as cleaner option. So this again is a summary of the previous slide. As you can see, it shows how many times each vehicle segment and fuel type is emitting more than their respective lab limits. For example, you can see more of the red color near commercial vehicle segments, which highlights the fact that the commercial vehicle segments are disproportionately emitting much higher than the lab. as I mentioned earlier, this remote sensing data is powerful in terms of comparing in between manufacturers also. So here we looked at BS6 CNG light goods vehicles fleet. We observed that one particular manufacturer, OEM2, as you can see here, is emitting disproportionately higher as compared to other two manufacturers which we captured. Again, this is in previous slides, you have seen the comparison with respect to type approval or lab limits, whereas in this slide, you're seeing the comparison with respect to our PUC standards. I'll just explain one data point here. If you can look at light goods vehicles BS4 CNG, almost half of the fleet of this vehicle segment is having real world emissions almost more than 2 times as compared to the lab limit for hydrocarbons.
Sorry to interrupt. Yeah,
Yeah.
I think nearing the end of this session.
Yeah, this is my final slide. So broadly, these are the findings that real world emissions from transport vehicles are much higher than lab limits with few exceptions. In all cases, BS6 were the cleanest out of the entire lot, whereas the real world emissions for BS6 vehicles were also much higher than lab limits in many cases, as I've shown earlier, especially for commercial vehicle segments. Also, the commercial vehicles were found to have significantly higher emissions than private vehicles, private cars. The CNG, which is generally considered as a cleaner fuel option, exhibited lower particulate matter emissions. But on the other hand, it came at the cost of very high NOx emissions. So the final submissions or submissions to the authorities were that CNG is not a cleaner alternative, at least in regions with poor air quality like Delhi. Retrofitting of vehicles to CNG without proper checks will not be beneficial. There should be new standards of emission standards for vehicles, next phases of BS6 and probably BS7 by 2028, which will introduce stricter real world emissions testing. The AAS 170, which has been lying dormant or which has been lying in the draft stage since 2020, should be finalized soon, and the authorities should start piloting this technology. And our PUC testing could be complemented well with real world monitoring technologies like remote sensing, because PUC, while it is important for detecting malfunctions, remote sensing can be more important in developing a phase out program for gross polluting vehicle segments. There are certain vehicle segments that could be supported for zero emission vehicle transition, starting with government fleets, as we saw that buses were emitting very high as compared to other vehicle segments, whereas the private commercial operators could be encouraged for the uptake of zero emission vehicles through incentives and policies like low emission zones. And agencies like CAQM can explore enforcing a ZEV sales mandate for commercial vehicle segments, which will also give direction to the industry. Now I will hand over to Mr. Sumantra and yeah. That's it.
Okay. Thank you, Anirudh. Quite an interesting, comprehensive presentation and quite some eye-opening information there. And I'm sure, and I hope the concerned authorities take note of that, and which at various points, ET Auto has also served as a platform to bring out such critical information, which is required towards as we make efforts towards a more sustainable future, and where cleaner transportation will play a very, very crucial role. Once again, thanks, Anirudh. And now would like to invite your colleague, Murthy Nair, to share a presentation on findings from impact of a low emission zone on air pollutants. This is a case study from the Pimpri-Chinchwad area of, which is in the outskirts of Pune. Over to you, Murthy.
Thank you, Sumantra. Let me quickly share my slides. Hope my screen is visible.
It is, and you've got another 15 minutes. Yes, please go ahead.
Sure. Okay, so yeah, good evening all. So I'll be talking about a concept or a policy measure that has actually gained significant momentum in European cities, which is called as low emission zone. So in general, low emission zones are basically a sub area with a defined boundary within the city where operation of a particular category of vehicles are either restricted or are allowed by charging a fees. So some prime examples are, cities like London has implemented low emission zone from past 10 years plus. Cities like Milan, Seoul, Brussels, Berlin are some global examples. Whereas particularly if you look at India, we don't have any city that has officially delineated an area in terms of low emission zone. The terminology low emission zone might not be maybe very new, but the concept is quite old. We have examples from Taj Trapezium, where the vehicles are restricted within the 500 meters boundary. We have Mathiran in Maharashtra. We have Kevadia from Gujarat, and we also have Kala Ghoda, which has been recently pedestrianized, that is in Mumbai. So we have examples from India as well. So in general, the global cities who has implemented low emission zone has, notably seen an improvement in air quality by restricting the vehicles. So it's not just limited to air quality benefits. There were additional benefits in terms of reduction in traffic congestions, greenhouse gases reduction, increased public transport usage, greater adoption of cleaner vehicles and zero emission vehicles, rise in active modes of transport, all were observed by these cities. So in total, ICCT has now supported 3 cities in the state of Maharashtra, namely Pimpri Chinchwad, Pune, and Chhatrapati Sambhajinagar, in planning and implementing low emission zone. So today I will be I'll be sharing some of our findings from one of these cities, that is for Pimpri Chinchwad. So moving forward, I'll quickly walk you guys through the work that we did for the past 1.5 years. So we started with assessing the city's air quality status, reviewing the existing emission inventory, trying to understand what is the contribution from the transport sector to the overall air pollution. All this preliminary set of studies is actually to build a case stronger for the city to implement low emission zone. And then what we observed was definitely the city did have higher level of pollution, breaching the ambient air quality standards, not as severe as Delhi, but yes, breaching the ambient air quality standard. The city did lack the basic emission inventory source apportionment study report to go ahead with. So whatever data we had was from IITM Pune, which was for the financial year 20, which reported 46% of particulate matter contribution coming from transport sector. So for the time being, we just use that as the baseline and we further move forward. But as a next step, the first and foremost was to develop emission inventory. So to develop emission inventory, which very specifically focuses on transport sector, talking only about exhaust emission, and we have not included non-exhaust emissions. So the next set was to the second set was to identify the emissions from the vehicle through emission inventory. The next process involved designating a low emission zone area within the city, which plays a very vital role in decision making. Then comes recommending vehicle restriction measures once the low emission zone has been identified, and then what should be the compliance timelines, and then if in case the low emission zone has been implemented by cities as per the recommendations and suggestions, what would be the potential impact on overall emissions. So with that overview, so the first and foremost was to, okay, now onboarding the city. So how do we sort of get the cities committed to this idea? So before we approached, the city was actually exploring low emission zone. So the Maharashtra state electric vehicle policy, which was notified in the year 2021, did come up with a notification which actually targeted 6 urban agglomerations, which included Mumbai, Pune, Nashik, Nagpur, Amravati, and Aurangabad. And they had targeted these 6 were targeted, asking them to develop a low emission zone. So that was a plus point from our end. And second was the clean air action plan. So second was the clean air action plan, where Pune urban agglomeration was identified as a non-attainment city. Pimpri Chinchwad falls under the Pune urban agglomeration, where the city is commit to reduce particulate matter concentration by 40%. So these two policy documents did support us a lot in onboarding the cities to get committed to this idea of implementing low emission zone. However, you can see this in the slide, the low emission zone measure was not uprightly mentioned in the Clean Air Action Plan document, but then it was reported that the city would be considering to take it up as an emergency response measure under the Graded Response Action Plan, which is typically, as we know, which is typically invoked when the air quality index surpasses a critical condition. That's what we see in the right hand side. With that, we did our first set of study was to develop a city specific emission inventory. This we did the study for 4 criteria pollutants, or the 4 major pollutants, and these are the results. So the results are actually based on our emission inventory study. The methodology is very detailedly discussed in the working paper, which I displayed in the second slide. You can refer to that if in case you are interested to know more about the methodology that was involved in developing these results. So we can see heavy duty vehicles were actually the major contributors for particulate matter and NOx emissions. Obviously, it's diesel vehicles that contribute more compared to that of the gasoline for particulate and nitrogen dioxide. So this is obvious because the city sees a very frequent movement of heavy duty vehicles, as the city is known for its automobile and mechanical industries. And when it comes to carbon monoxide and hydrocarbons, it was prominently from petrol operated vehicles, and it is obviously from two wheelers because of the higher number a higher number of vehicles that are operating on road. So these results served as a basis for the cities to sort of decide which vehicles has to be restricted based on their air quality goals, prioritizing those with the higher emissions. So cities can basically choose, okay, which are the vehicles that I need to restrict within the low emission zone on priority, and then see the anticipated benefits in terms of air quality improvement. With that, the second set of a second objective was to, okay, now we have identified the vehicles based on emissions. Where do we restrict these vehicles? Okay, can you tell me which area needs to be delineated as a low emission zone? So what we did was we identified 2 potential zones within the city to be designated as low emission zone through a thorough analysis. And these zones are basically prioritized based on several local set of information that included spatial temporal PM 2.5 concentration and population distribution to understand the exposure and the vulnerability, road network to consider the contribution of transport. We used road network as a proxy. We also considered local infrastructure such as schools, colleges, hospitals, charging station, public transport facilities availability, etc., to come out with a very detailed delineation of low emission zone. So again, the methodology is very detailedly provided in the working paper. One may refer if he or she is interested. So one is a smaller area, as you can see, which is 16% area of the Pimpri-Chinchwad Corporation, and the other one is close to 50% of the area. As bigger the area, more is the emission that the city can address through this policy measure. Now, the reason why we chose a smaller area and a bigger area is ultimately the decision is up to the cities to finalize the zone. The options that we are providing is one is smaller while the other one is comparatively larger. The larger zone affects more number of vehicles. So more the number of vehicles that are affects requires more compliance measures and investments in supporting mechanism by the city. It requires more manpower, more financial resources, etc. So the choice of ultimately choosing the zone depends upon city's readiness and preparedness, both aligned with the city's air quality and climate objectives. So these are the 2 sets of zones that we have proposed to the cities. Moving forward, the next set is to come up with the timeline. So as you can see, this is the timeline. So 2023 is the base year that we have considered, and from 2024 to 2030 is the period of implementation. With the first 2 years, the city will be completely investing on planning phase. That includes assessing the baseline pollution levels, traffic scenarios, setting up the emission reduction targets, developing policies, regulations, looking into the legal frameworks, setting up enforcement mechanisms, support mechanisms, incentive mechanisms, exemptions, etc. So entire documentation and infrastructure setting up for the enforcement mechanism will be taken care during the first 2 years. And from 2026 onwards, the actual enforcement of vehicle restriction begins. So it includes implementing vehicle restrictions, tracking the progress through surveillance, taking action against defaulters, track effectiveness of all the support measures that has been enforced, and regularly upgrading and as required. Communication, IEC activities will go hand in hand throughout the period of enforcement. So the basis for this timeline is again the Maharashtra State Electric Vehicle Policy, which was for the 5 years from 2021 onwards 2025. So what we assume is By the end of 2025, by the year 2026, six begins, these 6 cities, out of which one is Pune urban agglomeration, Pimpri Chinchwad, will begin enforcing low emission zone. So that's the basis on which we have developed this entire set of timeline. Now that the vehicle emissions are very clear, the zones are clear, the timelines are clear, how do we sort of go ahead and restrict the vehicle? So what should be the basis of restricting the vehicle? So again, what we came up was with 2 sets of scenarios where vehicles could be restricted. So one was to restrict the vehicles based on the age of the vehicle. Second is restricting the vehicle based on the emission standards. So one example is, obviously, if you look at Delhi has restricted vehicles about 10 years for diesels from operating, and petrol, CNG, LPG above 15 years are prohibited. So we applied the same set of policy measures here. What if this could be implemented within the low emission zone, and how this could actually improve the emissions or the pollutions? So this is something which we explored. The second was the typical emission standard based, which has been implemented by global cities within the low emission zone, restricting based on the BS standard. So again, the diesel will have much more stringent standard because it has got much more harmful emissions compared to that of gasoline, and gasoline will have a one-step relaxed emission standard. So one thing what we observed was when the cities just realized that they actually exhibited a greater level of confidence when they learned that a similar set of restrictions has already been implemented in another Indian city. So first and foremost was looking at how other cities, if in case they have implemented a similar restriction. So that's the reason we took Delhi. And so based on this, we have designed 2 set of restriction measures. Now, once we have these restriction measures, then definitely there will be a sub scenarios. That is, once the vehicle is restricted, what happens to the drivers? What will they choose as their next step to commute? So that's been developed. You can see in the right hand side table. So once the driver decides to stop using the vehicles that do not comply with the low emission zone, it is assumed that they transition to one of the vehicle options that is mentioned in the right side to meet the LEZ requirement. So they give up on their old vehicle and they might shift to probably a second-hand vehicle, but well within the compliance regulations, or else they shift to a brand new vehicle to meet the compliance, or else they will shift to a zero emission options. That could be use of public transport infrastructures, or use of active modes, or even buy a EV. So these are the sub scenarios which we modeled, so that our estimations do not be, it's not an underestimation, and we can actually get a clear picture of how emissions vary over the years. So with these, now we have 2 sets of emission. Now it is time to sort of finalize which one gives the city yields higher results. So this is something which you can see on the graphs, clearly indicates how age-based restrictions and emissions through age-based restrictions as well as emission-based restrictions vary, both by the end of the year 2030. So our period of implementation is from 2026 to 2030. Both gives a reduction up to 80% compared to that of the base year 2023. So one thing what you can observe is this is particularly for particulate matter that I'm showing. Similarly, we have done it for nitrogen dioxide, carbon monoxide, hydrocarbons as well. Under particulate matter and nitrogen dioxide, what we observed was, under the business as usual scenario or the no LEZ scenario, there is still a reduction because of the improved BS6 standards. Now, upon superimposing low emission zone, what we observed was this could be further increased. The improvements could be further increased up to like 30%, reaching up to 80%. So that's the benefit of adding a low emission zone to this. So from the age-based scenario, you can actually see from 2026, there is a huge drop that you can see from 25%. It reaches all the way down to 58 to 60%. Because of the larger number of vehicles shifting to cleaner and better efficient options. Whereas with respect to emission standard based, the restriction that we impose on 2026 is on BS1 and BS2 vehicles. Since these numbers are comparatively less, you can see the improvement is just 5% of above the business as usual scenario. But then this later builds up over the years, and by the end of the year 2030, the improvement for both age-based as well as emission-based is more or less the same. So now the cities can definitely choose more the number, as I mentioned previously, more the number of vehicles means more investment in terms of support systems, more compliance measures, etc. Whereas in the right hand side, the city actually gets additional couple of years as well, where they can plan their entire systems efficiently by the time they address a bigger chunk of vehicles. So with this, this is year over year improvements. Now, if the cities are supposed to look at an overall cumulative improvements, this is something which we notice. When I say cumulative improvement, it is not just limited to particulate matter, it is beyond particulate matter, but then looking into particulate matter, nitrogen dioxide, carbon dioxide, carbon monoxide, and the hydrocarbons. So all together, what would be the improvement? So what we observe is a higher improvement is obviously in the particulate matter level, which can go up to 52% if you go with the age-based restriction, and it can go up to 28% if it is a standard emission standard-based restriction. So overall reduction up to 24% is possible, provided vehicles are the drivers who give up their vehicles shift to zero emission vehicle options or the zero emission mode of transport. So the policy should be designed in such a way that the drivers who actually give up on their vehicles are made to shift towards zero emission vehicles through lucrative financial incentives and other support mechanisms. With this, I'll move to my final slides. So final slide is just summarizing some findings. We did come up with two sets of zones, zone 1 and zone 2, zone 1 being smaller and zone 2 being a bigger one. Definitely zone 2 achieves a 3 times more emission reduction. Bigger the zone is, bigger the improvement. At the same time, bigger chunk of vehicles gets impacted, and they will be shifting to cleaner technology. However, the final selection depends on cities' readiness and preparedness in alignment with the air quality and the climate goals. Whereas in terms of emission ranking, altogether cumulatively, it was two-wheelers, heavy-duty vehicles, light goods, light motors, medium goods vehicle, heavy passenger vehicles, medium passenger vehicle, three-wheelers, and light passenger vehicles. This is the hierarchy in which the emissions from the vehicle used to happen. Now, the restrictions, what we are recommending is a uniform restriction across all the vehicle categories. However, cities can choose or prioritize the vehicles based on their readiness and preparedness. When it comes to restrictions, age-based restriction outperforms emission-based restriction, but then again, cities can choose a much more lenient option at the beginning, and which can be strengthened over the years and make it much more stricter as we reach the end of enforcement timeline, which is 2030. So again, it's up to the cities to finally choose which emission-based restriction they would like to go forward with. More importantly is the support mechanism now for any vehicles to shift, or there should be an alternate system that needs to be provided, a robust demand side measures such as reliable public transport, financial incentives to scrap old vehicles, and interim exemptions if in case needed needs to be provided. So this actually will complement the entire implementation of low emission zone that we have planned within the city. The last but not the least is the regional expansion. So following Pimpri-Chinchwad successful implementation, and the results are visible for the identified low emission zone. The LE said the low emission zone should be now scaled to the nearby cities, covering entire PCMC as well as the neighboring cities, and move towards more of regional level low emission zone, or else they should opt for much more advanced zero emission zone, where all the petroleum based product based operating vehicles are restricted, and the permission is only granted to the operation of electric and zero emission vehicles. With this, I would like to end my slides here, and over to you, Sumantra.
Okay, thank you, Murthy. That was quite interesting. And before we let you go, just what is the recommended restriction type by ICCT in terms of, would you think the age-based or the emission-based? Because there seems to be this debate among consumers also. Someone may say, I mean, if you go by age-based, how does it matter? I mean, because if I have a, let's say in Delhi, maybe a 15-year-old diesel vehicle, a diesel Scorpio, or a 20-year, very fine, immaculately, in immaculate condition, as compared to a 5-year-old Scorpio, which is perhaps not so well in, then it's obvious which one should go out of the road first. So in such a scenario, which one do you think is more kind of effective? Rule, but yes.
Yeah, so here what we observed is, from the enforcement point of view also, it's quite challenging because we don't have more of information about what emission standards are this vehicle registered with for the vehicles prior to 2017. So if you look at the RCs, this information is not actually available, which could be a loophole in implementing and enforcing this. That is point one. And point two is, right now, with respect to emission based, the maximum we can go is up to BS6. and we need to wait for BS7 to be implemented so that you can restrict BS6. Whereas in age-based, this is continuous and it keeps on moving irrespective of BS7 is present or it's not present. So from the enforcement point of view, age-based is much more easier. But then, as you mentioned, this kind of caveats are there in both the cases. Even BS6 vehicles also, if not maintained properly, they tend to emit large in that of this. But then, if I'm looking at the short-term measure, age-based did provide us a more kind of improvement because there is larger number of vehicles that are going out compared to that of this. Accumulative improvement is higher.
I think that's a fair argument. So what you're saying that in the current scenario, chances are that you will achieve more by an age-based restriction than an emission-based.
Yeah.
Great. Thanks once again, Murthy, for that was quite interesting and informative, and I'm sure the audience would also agree with me. Now it's time to bring on the experts onto this virtual stage. So let me invite Pallavi Pant, Kaushik Deb, and Amit Bhatt also. Please switch on your cameras. And to start off with, I would request each of the experts to clearly share your kind of perspective on the theme of what we are discussing today, which is road to clean air, policy and technology solutions for reducing vehicle emissions. So why don't we look at because at the core of it is health, right? So let me bring in Pallavi Pant, who is the head of global health at Health Effects Institute, to hear her perspective on how we can really, what kind of levers, what kind of policy or technology interventions we need to do to ensure our good health. Over to you, Pallavi.
Thank you very much, Sumantra, and also thank you to Anirudh and Murthy for these really excellent dives into specific policy interventions. I think, I'm just going to take us back a minute to start with this idea that the reason we are worried about emissions from vehicles is because we have large numbers of people that are, living very close to roads. So they're getting exposed to a lot of traffic emissions every single day. And these emissions are not just contributing to the air pollution near the road, they're actually contributing to air pollution much farther than where they're getting emitted. And also these emissions are complex. I think we already heard it is not just about particulate matter, it's also about other types of pollutants, including variety of gases such as nitrogen oxides, which unfortunately in many Indian cities are increasing. And then the other thing that happens along with that is if you have an increasing level of nitrogen oxides, you add sunlight to the mix and you add volatile organics to the mix, which, by the way, vehicles are also emitting, we end up with secondary pollution. So things like ozone, which is not emitted from any tailpipe, it's not emitted from any pollution source, but gets produced in the atmosphere through chemical reactions. So vehicle emissions clearly are very close to us, but impacting also air quality and people's health and farther away from just the near road environments. And B, it is not just about particulate matter when we're thinking of traffic emissions, it's really a mix, a cocktail of pollutants, as we say. And the other piece, which we are not discussing in detail today, but is very relevant, and we are not really, discussing it in the same way in the Indian context, is of course the non-tailpipe emissions, particles that may be coming off as tires, get older, and you're running them on the roads constantly. There's abrasion also of the road surfaces. Brake particles can go off, and all of these are also going into the air. And as vehicles continue to drive, they get resuspended. We're breathing them in. And a lot of them tend to be high in heavy metals like copper or iron, which again have implications for health. A lot of times we hear about the various ways air pollution is impacting our health, but actually just to bring a finer point to the issue for traffic-related air pollution in particular, so not talking about air pollution in general, but just traffic-related air pollution, we have very strong evidence from studies around the world of connecting these exposures to traffic-related air pollution with cardiovascular disease, so heart disease, lung disease, and even things like asthma. And I'm not talking about asthma exacerbations, but actual onset of asthma, both in children and in adults. So this is not just making the problem worse or making a disease worse, it may actually be creating the disease in the first place. And some of you may have heard about this, very landmark case. It's very unfortunate, but it has, really brought the issue to fore. Is the case of Ella, who was a 9-year-old girl in London, died at this age of 9, and her death was ultimately attributed to exposure to air pollution. She also lived near a road. She also was exposed to traffic-related air pollution, nitrogen oxides, and other pollutants. So we also have examples of, very real implications for this. And I think to end this, I will just say we heard about low emission zones and also about the various ways that cities can reduce emissions. I think the only thing I will also ask us to remember is that, as we've seen in Delhi over the past few weeks, emissions are one part of the story. What's happening with land use, what's happening with the local meteorology, what may be happening with how vehicle flow is determined is also critical, because that can help us reduce exposures and emissions over time. So as we think about technology solutions, the road to clean air will also require behavioral solutions. It will also require land use and urban design solutions. And collectively, we need to look at that whole package in order to see those improvements that we're all looking for and the blue skies that we all want.
Thank you. Thank you very much, Pallavi. Very well said. And I can't agree with you more, especially when you talked about the need for behavioral solutions and urban design solutions, because increasingly, especially in the metros and the big cities, urban planning, perhaps there is much room for improvement to also integrate these whole mobility solutions, and in a more smarter way. It's not that they are not there, but in a more smarter way to ensure that we have a cleaner transportation, cleaner mobility for all. Thanks once again, Pallavi. Please stay online. We'll come back to you again with some questions during the discussion. Now it's my pleasure to invite on stage Kaushik Deb, who is the Executive Director at the Energy Policy Institute at the University of Chicago. Kaushik, your thoughts, please.
Thanks. First of all, much gratitude to Amit and Vaibhav and everyone at the International Council for Clean Transport and at ET Auto Sumantra for having me part of this conversation. This is extremely timely, extremely important, and super useful. The presentation that Anirudh and Murthy made were really, really revealing and kind of talked to a lot of the issues that we at the Energy Policy Institute at the University of Chicago, EPIC, no modesty here, kind of spend time working on. And in many ways, kind of the way I'm seeing this conversation happen between us, it almost seems that we're speaking to the converted. All of us are very diligently and actively agreeing with everything that's being said and being done. So let me kind of inject a slight dose of controversy, if I can, and make this conversation a bit more interesting. And I'm going to pick out my good friend Amit, because I know that I can, and he won't get mad at me. One of the things that Amit kind of said in his introduction remarks was the air quality in the Indo-Gangetic belt is bad, but only slightly more so than the rest of the country, and kind of remains bad for most times of the year. I'd argue that it's significantly much worse than elsewhere in the country. I mean, of course, none of us have had the pleasure of seeing the crisp blue skies that Pallavi seems to have come to this webinar with. This really amazing background of crisp, clean, cold air that you would get to see at some point, perhaps in the mountains, but none of us have had the privilege of getting that apart from the brief period of the lockdown and the COVID. But what happens in the Indo-Gangetic belt in North India for almost half of the year is extremely, extremely disturbing and distressing. Pallavi kind of talked about some of the detailed health benefits, health impacts there. And if I can kind of talk to all of that as well, I mean, in our assessment, we run the Air Quality Life Index at the University of Chicago. Air pollution is the leading cause of human death in our math. It's more than the impact that smoking has, or alcohol consumption, traffic incidents, HIV/AIDS, all vector-based diseases like dengue or malaria. So air quality is truly a massive killer globally. And that's kind of one reason why I think even slight improvements can have significant impacts. What Amit was saying, that significant improvements are possible by us just kind of moving forward on the agenda that was being presented today. I found the presentation that Anirudh made extremely motivating for the work that we also do. As inadequate as the PUC system in India currently is, our assessment of this regime in Delhi is that there are significant improvements in even achieving these very trivial or limited standards that the PUCC system kind of puts in place. In our work in testing the PUCC system, we kind of visited 22 randomly selected PUC centers across 9 districts in Delhi, and we found that at 5 of these centers, vehicle tests were being kind of failing almost on a continuous basis. In one case, kind of there was significant issues around leakages and corruption in terms of how the system was being operated. And the problem, I think, becomes a lot more worse, as Anirudh was also describing, when it comes to diesel vehicles, because the way the test is actually conducted, even in the limited opacity standard that exists, does not inspire a great amount of confidence. And we did observe a fairly significant amount of both violation, but also manipulation in the way the regime is being implemented there. So even moving from a point where we are today of inadequate implementation of the PUCC scheme to a point where remote sensing based very effective regime can be put in place in a city like Delhi or any of the urban agglomerations that we have around the country suffering from very terrible air quality, the impact can be extremely significant. And I'm sure that there are ways that we can also try and quantify that in terms of not just emission savings, but also in terms of improvements in the air quality and the necessary kind of impacts around health and life expectancy. And that's really the way one wants to kind of make this progress happen. Just the transition to remote sensing based emissions monitoring is clearly important, and I think is also a very significant way of taking away discretion in the way this regime of maintenance of vehicles or testing the maintenance of vehicles is actually implemented. The conversation that you just had with Murthy in terms of whether an age-based criterion is the appropriate one or not, and whether a new vehicle which is poorly maintained performs should be penalized more than an old vehicle that's better maintained. If you have this technology-orientated regime which does not involve human discretion, I think one is able to take away a lot of the possibility of the potential for discretion, as well as manipulation that would ordinarily happen when you are trying to kind of have these arbitrary standards being put in place. And that's really, I think, to me, the exciting part of making this improvement. And the fact of the matter is that from the work that Anirudh kind of presented, this is eminently doable with existing technologies and existing costs and existing regimes. And there is a legal framework to get that done. And that's really the path that EPIC has chosen to go down with the Transport Department in Delhi, where we are trying to kind of see how best can this regime be made more effective to meet the air quality that we truly, all of us deserve, not just children living besides high congested traffic roads. I'll stop here because I recognize that there's a very limited time available and lots of people have kind of popped up with questions, but I'm happy to chime in more with zero emission zones and other work around the whole part around behavior and changes in how we consume transportation services happens.
Sure, that's much needed. Thank you so much, Kaushik, for your initial remarks. Amit, as an agency, you work quite closely with the policymakers and giving very valuable inputs towards cleaner transportation. tell us in terms of, since we are also talking about technology interventions and policy interventions on the technology side, as your colleague also mentioned, that what is seen as what is being perceived, or I mean, much debated or discussed about as a one of the relatively cleaner options of CNG, perhaps is still not clean enough. So in such a scenario, and given the environment in India, what would be the best technology solutions?
No, absolutely, Sumantra. And I think, again, we also have to look at the CNG story in a slightly broader context. Maybe 2.5 decades back, when the whole conversation started along with the implementation of CNG, maybe CNG was the best available technology at that time. And therefore, I think kudos to the government and folks who came together and did this massive transition, at least in Delhi, which kind of kickstarted the CNG story in India. But I think we have now realized that technology has always also evolved. And we now have much better technologies than what we had about 2.5 decades back. So that's one. So limitation of technology one. But now we are seeing that zero emission vehicles like electric vehicles are not only cost competitive, we are seeing a greater appetite of the transition happening around the world, and electrification of transport is seen as a solution, not only from public health side, but also from the climate side, as well as from the industrial productivity and transition side. So now, so that's part number 2. Point number 3 is that if Delhi can transition to CNG, and in fact, if we can leapfrog as a country from Euro 4 to Euro 6 or BS4 to BS6, we can also leapfrog this investment, this transition. So I think what we need to do, 2 things. One, kind of develop a robust roadmap for this transition. And second, as Anirudh presented in the segment, that if commercial vehicles are the gross polluting vehicle category, then can we accelerate the transition of these vehicle categories at the earliest? So for example, taxis are anyway shifting to electric, but what about goods vehicle? And that is a major issue. So I think the PM E-Drive scheme, which has come, which has allocated some money for electric trucks, we are hopeful that will kickstart a conversation. But we have to definitely develop a robust plan for transitioning commercial vehicles to electric as a priority.
Indeed, that makes sense. And also perhaps along with that will emerge new options or services which will kind of help lighten the burden of the technology cost, which to be borne by the operators. For example, we have seen recently, especially this is more in the passenger vehicles, introduction of the battery as a service option, wherein which it makes it the consumer not the load, it lightens the load significantly, the consumer. Perhaps something like that could also help kind of pave the road better for commercial vehicle electrification, I guess. Well, coming to Pallavi again, whenever we have these discussions around air quality and the kind of proportion of transportation related pollution in the environment degradation, we usually talk about, more often than not, we talk about PM, particulate matters, where they are definitely the villains, but there are some other villains as well, right? Like NOx and some other elements which have a very significant impact on human health. Could you throw some more light on these aspects and also kind of propose some ways by which we can address these challenges also, the lesser known devils?
Yeah, thank you. I think, as I mentioned, the emissions from transportation in particular, and this is true for many other sources of pollution, tends to be complex. So it's a mixture of gases and particles, and there's heavy metals in there. There are carcinogenic compounds like polycyclic aromatic hydrocarbons. It's a mouthful. But one of the pollutants that has been really discussed in the context of transportation in particular is the nitrogen oxides, which are emitted directly from the tailpipe, can also contribute to the formation of other pollutants in the atmosphere. So really a critical piece. And again, exposure to this mixture of traffic-related air pollution has been linked to a variety of health effects. I already mentioned some of those, so I will not, necessarily risk repeating them, except perhaps to say that, in many places around the world, we have actually seen significant improvements in terms of reduction in nitrogen oxides, reductions in, levels of particulate matter as well, as engine technology and vehicle technology has improved, as more stringent regulations have been introduced in the transportation sector in particular. But there are still many places where this remains a problem, and India is not unique in that context. At the same time, people have thought about ways to address this. I think, we're discussing specifically sort of leapfrogging to more stringent emission standards, which is a very good pathway to try and reduce emissions. Low emission zones, which we also heard about from Murthy, have been another way that cities in many places have tried to restrict, the emission that is happening. And in fact, some of the recent evidence is starting to show that use of low emission zones can be a beneficial way to improve air quality, and not only improve sort of, air quality, but improve the quality of life for people as well. It can increase physical activity, which is also beneficial for our health. How many of us objectively want to walk, next to a road when we know it's very polluted, or be even in a marketplace when it's very polluted? But if we implement these measures, it can help improve physical activity levels, reduce air pollution, also, just improve the quality of life for people. And in addition, I think, there are examples that are beginning to emerge from some cities. I think one that has been somewhat controversial as well was the super block idea in Barcelona, where they've actually taken, parts of the city and really done a turnaround entirely. So spaces for parkings removed and more green space created, which again is really good for our mental health and for our health overall. So I think the piece that I would again put to the front is thinking about transportation within the context of how our cities operate. And our cities are complex, and we already have like very dense sort of zoning that happens, but how can we create pockets of respite which implement solutions that are going to improve air quality, but also bring in other urban design solutions, ultimately aiming for, yes, better air quality, but also better health, better mental health, and really thinking about this as an integrated issue versus thinking solely about, let's fix air pollution, and that's what we will talk about. And, some other people will talk about how do we increase physical activity and how do we create better green spaces. So this would be my call to say, let's think about all of it together, because that's what will bring us the most benefit overall.
A holistic approach is the need of the hour, as you rightly said. Kaushik, as I understand, EPIC India has been also collaborating with the DTC the Delhi Transport Department to really improvise or enhance the PUC testing regime, as you also touched upon about PUC in your initial remarks. In fact, I believe you had also conducted joint surprise tests with some vehicles. So what you have already shared, but can you throw some more insights about what you have found from some of these tests?
So it's kind of interesting in terms of what outcomes we found. So as I said, we did 22 randomly selected PUC centers across all the 9 districts in Delhi. Now, even when the standard operating procedure was followed, at 5 centers, vehicles still failed tests. But none of these failures were recorded in the NIC database. So that's kind of an interesting observation, that you can still not achieve the outcome that you want, despite having followed the letter of the process to the T. The second thing that I think is kind of significant is the particular failure of the regime to deliver on testing results for diesel vehicles. And as kind of Amit noted, as also in the presentations earlier, this forms a fairly disproportionate part of the passenger of the vehicle kilometers in any urban agglomeration. And as long as one is able to kind of deal with diesel vehicles in a very, very effective fashion, you have solved a fairly large part of the emissions from the transportation sector problem. And at none of the centers where we did the surprise tests, were able to conduct a valid test for diesel vehicles due to non-compliance with the RPM requirement. We also saw that there was a fair amount of discretion and manipulation of data. At 7 centers, we had these operators manipulating data using readings from another vehicle that was tested. So it's like if Amit's car passes the test, I kind of piggyback on his test results and get my sticker saying that I'm in compliance. And I mean, there are fairly easy, fairly simple ways of doing all of this, including tampering of probes, issuing fraudulent certificates, not following the process to the T. And all of these are essentially ways that, essentially discretionary ways that the system currently operates in. And that I think can be dealt with by moving to a more technology oriented solution. But Sumatra, if I can just also quick, one of the questions that you asked, Amit, for instance, was that what's the best available technology for us to be able to kind of meet our answers today? And kind of Amit took me back some way back in time, 2.5 decades back, when I started my career in this space, looking at Delhi's transformation from diesel to CNG in the commercial vehicle space, including for buses. At that time, when I was part of the institution called the Energy and Resources Institute, we actually did carry out tests between CNG vehicles and the ultra low sulfur driven diesel vehicles at ARAI using a variety of different driving cycles, Indian driving cycles and the European driving cycles at their testing facilities. And even then, there were situations where emissions from the CNG bus chassis were worse than what we got through the ultra low sulfur diesel vehicles. And that entire transformation essentially at that point was being driven from diesel to CNG because CNG was clearly a preferred choice, technology choice for the transportation sector. And the driving factor of why CNG performed sporadically worse than ultra low sulfur diesel was because of the vehicle maintenance and the vehicle quality. Essentially, what happened was that when the mix between the lubricant and the fuel went awry, CNG vehicles were through the roof in terms of NOx and hydrocarbon emissions and VOCs. And that's kind of an issue of concern, right? So when you start mandating technologies, and clearly everyone is completely gung-ho on electric vehicles today for very, very good and obvious reasons, but let's not kind of be in a situation where we are technology tied without having the opportunity of finding something which may be remarkably different and brilliant somewhere on the horizon. So that's just kind of one note of caution I'd kind of add in terms of mandating a technology.
That's a very valid perspective. Indeed, as someone also said, a very senior global industry executive a couple of days, some time back, and said that we shouldn't pick the winning horse. In fact, sometimes we may end up, we may run the risk of ending up choosing the wrong one. But however, we should create a scenario where they compete, and then the winning horse is identified in terms of the policymakers. But in the current scenario, there is also an argument that when it comes to cleaner options, the electrification kind of is in terms of the maturity, in the maturity curve, it's a little ahead from all the other emerging, among all the emerging options. So I think it has to be very well thought out policies for us to achieve sustainable goals. We have seen some very good engagement from our attendees, panelists. So if I may dip into the questions which I can see on the screen. So here is one. Here I would also request the presenters to address some of these questions. So for example, there's one question on how did you get the emissions from HDVs separately? Is it national or state? In case it's state or city level, have you used registration data or surveys? I think this will be for Murthy. Murthy out there?
Oh yeah. So we have actually responded this through the Q&A box. Do you want me to repeat the answers?
Okay. All right. I think for the benefit of all attendees, you may very briefly touch upon the key points.
Yeah, so what we did was we initially conducted a survey within the city in parking lots as well as fuel stations, where we collected 4,000 samples of vehicle samples to understand the vehicle characteristics. This included the age of the vehicle, the fuel used by the vehicles, how much do they travel, how much do they spend on the fuel, etc. That included heavy duty vehicles and all other categories of vehicles. So basically, so that we get a tailored answer for all this emission inventory related questions and final results. So we did use registration data as well as we are conducted surveys. So it's a agglomeration of both combined, so that we get a very good output.
Thank you. This question, maybe I would request both Amit and Kaushik to respond to. So as you said, CNG is no better over diesel. Why not use diesel vehicle with hybrid technology?
So maybe I can come in and then Kaushik can later on add. So if you look at what Anirudh presented and in the real world emission, and we actually mapped 4 criteria pollutants. So carbon monoxide, hydrocarbon, particulate matter, and NOx. And this for Delhi fleet, which is predominantly CNG. So what we found that in case of particulate matter emission, diesel's vehicles were the kind of top polluting vehicle category vehicle segment. But for the rest of the 3 vehicles, we found that CNG had a was the predominant fuel type. And so one is that because we captured a lot of CNG vehicles, so that could be one reason. And if you probably perform these tests somewhere else, we might get a different story. So the bottom line is that so the air quality we breathe is impacted by the vehicles that operate on our road. But the testing we do is when the vehicles are stationary in a lab condition. Now, this is a major discrepancy. And we are not saying that the vehicles will perform like they are in lab values. There will be some difference. But what should be that level of difference? 50%, 100%, 200%, 2000%. I think that is a major issue. So once we start collecting this real world data, we will know that what is happening with the emission on vehicle. There could be certain fuel types that will perform bad, we will take action. As Anirudh presented, there could be certain manufacturers who would be performing bad. So we can take action on those as well. So once we start getting this information, we can take really concrete policy decisions, which currently we are going more based on our intuition.
Okay. Kaushik, want to add?
So it's kind of what Amit said is absolutely on the point. And I think kind of that's the discrepancy between what we know, what's happening in a test lab condition, and what we are actually realizing on in real life. That mismatch, we certainly have to kind of bridge somehow. But I'll kind of just go back and wear my transport economist hat for a minute. And the way I kind of think about this is that instead of mandating a particular technology, we use a technology to set that benchmark. And for anything that meets that benchmark and goes above and beyond that should be something that we would encourage and allow in the market. So at this point, as we've kind of chatted over the last hour and a half, electric is the most efficient and effective solution. Now, if that sets the benchmark, anything that gives us a result better than that, either by way of cost effectiveness or by way of emissions performance, we should kind of definitely allow and bring into the market. But that's the kind of benchmarking that's kind of helpful for us to make progress in the most efficient way. I mean, this is University of Chicago, Department of Economics. This is kind of Milton Friedman and everything of the like. So the invisible hand of the market in terms of identifying technologies should work the best.
All right, sure. I think Pallavi, you would like to add your perspective on this as well.
Yeah, I think I'm not the technology expert, but I just wanted to, again, bring back two things. So one is we've known for a long time now that diesel engine exhaust is carcinogenic. It causes cancer in people. So that's just a useful background note to this conversation. And then the second piece is just that, we've already talked a little bit about it, but the issue of unintended consequences. In Europe, diesel was introduced in a big way as a way of, addressing climate. What we saw as a result of that was really high nitrogen oxide emissions as well, which many cities in Europe are still dealing with. So I think I will, go back to and press again on the point that Kaushik made, that we need to be thinking about the larger picture and trying to take into account as many unintended consequences of the decisions that may come to bear in future, just as a note to this discussion.
Great. I think we have. I just noted that we have run out of time, but it also is a reflection of the strong level of interest in this theme of the webinar. But with everyone's permission, if we can just take another 5-7 minutes, is that okay? Yeah. Great. So staying with the Pallavi, I mean, you join us from US, where also the infamous Dieselgate scandal was exposed, and we know the ramifications and also how it affected the entire global automotive industry. So considering that, no, I mean, the administration, okay, well, now there's a change of regime happening there. But having said that, is there anything that you observe from where perhaps India can take a leaf or two from the US book there?
I think, probably just the longer term story, which has been consistent and regular tightening of standards with a clear roadmap. People, including the manufacturers, including the people that work in the inspection and maintenance industry, people that may be working on other associated issues, have known what the trajectory is going to look like. So people have been able to be prepared. I think that for me has been a useful lesson. If we plan it out appropriately, bring along all the key stakeholders, we will be able to bring change more efficiently, and also keeping at the target. So we introduced Bharat Stage 6. Wonderful. I think that was a great thing that India did. Should we be stopping there? No, we should be thinking about, what's going to be next. So planning ahead. And then I think the other piece, which I may take from the European example in more recent years, is trying to integrate the transportation and air pollution decision-making into the larger city decision-making. So not thinking about it as a individual issue that needs to be addressed, but trying to place it very much within what a city is doing. I think Paris has some really good examples. London has some really good examples. And we may not implement the solutions, wholesale, what they did, but there are some very interesting lessons to be learned also on the behavioral side, because we don't just want people to switch over from petrol or diesel vehicles to EVs. We ideally want people to switch to public transport and more walking and more cycling. So I think there's a mix of lessons, but highlighting consistent planning and implementation, and also embedding air pollution decision-making in the larger context and not just looking at it as one single issue.
Well said there. Well said. Some inputs there from which can also perhaps help India in tackling its own challenges. Yes, there are certain unique factors to the Indian society as well, but some of it, I'm sure, can be implemented here, as also India kind of moves ahead towards achieving its goal of carbon neutrality, achieving carbon neutrality by 2070. So that's a big task, a tall task, even though we have got quite a number of years ahead. But considering the complexity and the size of India, it's perhaps it's just about enough, maybe. But the thing is, the sooner we the more smarter and, as you also said, long-term approaches we take, the better it is for us to achieve the goal of carbon neutrality. And within that, sustainable or clean transportation will be a key point. At this stage, I would also take this opportunity to announce to everyone here that ET Auto, which really is also takes upon itself as a key responsibility to kind of offer itself as a platform for driving the cause of clean transportation, is hosting the 9th edition of its annual flagship conference for the on the electric vehicle industry called EV Conclave, which is scheduled to be hosted on 11th and 12th of December at the Hyatt Regency Delhi. So to all attendees, to all panelists, I would invite all of you to the conclave. Yes, Amit is also there, and also it's a pleasure to have ICCT as a partner in this event. And as we say, increasingly it's in this disruptive and technology-intensive era, collaboration is the name of the game. And this initiative and the partnership which is there for EV Conclave is just a small reflection of that trend. But are we doing enough? The answer is no. But and at the same time, can one webinar like this address the solution? Definitely not. We need to keep kind of going, making efforts collaboratively, more stakeholders joining the fray, and I'm sure we will achieve that. So on that note, once again, thank you very much. And Amit, if you want to share your last concluding remarks before we log off from this edition of the webinar series.
No, thanks, Sumantra, for wonderfully hosting this webinar. I mean, I know we had 90 minutes, you've gone ahead of 10 or minutes, and if we allow another 90 minutes, we can continue the discussion forward. So I think, and that's the severity of the problem. But again, I'll thank everyone for joining, and I think we look forward to more such engaging discussions. And as you rightly said, the EV Conclave would be probably the next steps in terms of taking the conversation forward. So thanks a lot, Sumantra and ET Auto, for hosting the webinar.
Thank you, and thanks to you and your team, Amit and Pallavi. Thank you very much. Again, sorry for making your day a little longer today, but really appreciate you, for staying up till late there and by sharing your very valuable views and perspectives. Thank you very much, Pallavi. Best wishes to you. And to you too, Kaushik. Thank you for making it just in time, and hope to meet you sometime soon. Yeah. And to Murthy and Anirudh, thanks for your fantastic presentations. And to all the attendees from wherever you have joined, thank you very much for making this edition of the webinar series a success. Please keep sharing your views, feedback, and engaging with us however possible. So, and you can leverage the social media channels of ET Auto also to kind of share your feedback, and also leverage the platform to further the cause of sustainable or clean transportation. On that note, thank you very much, and best wishes to you and your colleagues. So till we meet again with the next edition of the webinar series, take care and goodbye.